Hey there. We're going to start talking about summary statistics. So how can we summarize data to try to tell a story? And there's a bunch of different ways to do this. But before we get started, we need to understand what we're trying to summarize. And those are things called variables. Now, a variable can be quantitative. That means it can be summarized using a number of some kind. And there are a couple different types of quantitative variables. There are continuous variables, which basically can be any number with decimals in between. They can range from negative infinity to positive infinity, basically. So for example, this little chick is 3.1 inches tall and weighs 34.16 grams. So that's one type of quantitative variable, a continuous variable. A different kind of quantitative variable is called a discrete variable. And a discrete variable might be something that you could count. And so you wouldn't have partial or decimal values, but you'd have, like this little octopus has 8 legs and 4 spots. Those would both be called discrete variables, and they are integers often, something that's countable that wouldn't usually have a part or a piece or decimal. So those would both be quantitative variables. Another kind of variable would be qualitative. And these are more like categories of things. So for example, a nominal variable is like a name. So turtles versus snails versus butterflies. Those would be different variable types of animals, and you would use a category to describe them. You could also have some kind of ordering there between like, I'm unhappy, I'm okay, I'm awesome, right? So those are categories, but they're also on a scale, they're ranked. So often like a Likert scale from like, I totally disagree to I kind of disagree to a neutral to I somewhat agree to I really agree, right? Those would be an ordinal categorical variable. And then you might have a binary variable, which would be like alive versus dead, off versus on, extinct versus extant. So binary are categories where there's yes or no, right? Things like that. So you could have a binary variable as well. So all three of these kinds of variables are categorical. And so again, continuous is measured along a smooth interval, something like temperature. Discrete is a variable that you can measure using an integer, like a count of individuals' age. And then categorical variables are any variable that's not a number, a color, a success versus a failure, a presence or an absence, yes or no, right? And there are different types of categorical variables. In terms of categorical variables, since I think we think about these less frequently, so what are some examples? So maybe just look around the room and think of some things that vary around you that you could put into some categories. So what might some of those examples be? Well, colors, species, habitat types, like the kind of 20 questions kinds of things. Is it made of wood or metal, or is it bigger than a bread box, smaller than a bread box? These would all be categorical variables. We're actually going to kind of put these aside, these categorical ones, and come back to them a little bit later in the course. Our focus for the next few weeks will be on the quantitative variables, the things that we can measure. Those are some of the most common things that we run across or are interested in summarizing for statistics. And then let's think just a little bit more about these variables. And I think it's easier to think about the quantitative ones in this case. We often are interested in 2 variables. Like we're interested in, say, the median annual, or the median annual income in, say, Olympia versus Tacoma. So in that case, we have median annual income. Income is the amount of money that people make. So that's, of course, a quantitative variable or a continuous variable. You can earn parts of a dollar, right? So that would be continuous. And but the other variable is the city. So Tacoma versus Olympia, that would be categorical variable. So we're often interested in two variables, and the dependent variable, the one that depends on the other, is usually placed on the y-axis, the upward facing axis, the vertical axis. And so in that case, income might depend on where you live, right? The cost of living might be higher in one of these cities versus the other. And so we'd often put income on the Y, and we might put city on X. The independent variable in this case would be city. It doesn't depend on the other income. So, you don't like look at your paycheck and say, oh, wow, I made so much money today. I must live in Tacoma this week versus, last week I didn't make very much, so I must live in Olympia. That it doesn't work that way. Like, right. So the money that you make might depend on where you live, but where you live, in this case, isn't determined by your paycheck, although you may make choices about where you choose to live based on how much money you might make. That gets really complicated, right? So, but in this case, the independent variable would be city, so it does not depend on the other and would be placed on the x-axis. So there's some convention here in terms of variables and where they get placed when we're building graphs. So try to think about which of my variables is dependent on the other one, and you'd put the dependent variable up here on the y-axis. So I think, yeah, I'm going to pause here and move on to the next video.